Okay, today we are going to convert rates and measurement. We will spend a few class periods on this. Make sure that you have your calculator and the handouts given you in class, especially the handout that has this chart on it, the measurement conversions chart. This is from your textbook, but I just wanted to make sure that you had it handy with you. So let's go ahead and talk about this. What does it mean to convert rates? Well, I like to think about it like this. So let's start off with an example. You're camping and there's a grizzly bear that's been snooping around your food, and it sees you and it starts to run after you. So we know that this grizzly bear can run about 30 miles an hour, and I want to know how many feet per second this is, because if you have a big grizzly bear running after you, you definitely want to know if you have a shot at outrunning it. So we're going to use a process called dimensional analysis, which I've mentioned before, to do this rate conversion. Dimensional analysis is the process of including units of measurement as factors when you compute. In the last lesson, when I said, hey, units can cross-cancel just like numbers when you're multiplying, that's what we are referring to here. You will use this process a lot in science classes, especially next year in APS. So let's go ahead and let's see, what does it take to change this grizzly bear's rate of 30 miles per hour into feet per second? The first thing you want to do is set it up just like I've done here. I have two rates, two unit rates, in fact, 30 miles per hour, feet per second. And note that these are equal. These are equal values. They're just two different ways to describe the same thing. So, yeah, how many feet per second is this grizzly bear running? Well, the first thing you need to do is write down what you know. We are doing two conversions here. We are changing hours into seconds, and we are changing miles into feet. So I recommend to first write down what you know. You may use the charts given you on your handout to help you in case you don't know a basic fact, or you can use your textbook as well. So, what's the basic fact that connects feet and miles? We know that 1 mile is equal to, again, 5,280 feet. So write down that rate. These are rates that we know, which we will be using to help us convert. Then we need to know how to get from hours into seconds. Okay, well, you might need to use a couple of conversions here. We know that there are 60 minutes in an hour, and we know that there are 60 seconds in 1 minute. So if I wanted to know how many seconds were in an hour, I would need to do 60 times 60 to get 3,600 seconds in 1 hour. So those are the basic rates that we know. And again, if you weren't sure about this 3,600, you could easily compute that, 60 times 60. So how do we now use these to convert 30 miles per hour into feet per second? Well, let's start with what we're given. The setup is really, really important. I am going to be looking for this specific setup. So please practice this when you are working through these problems. So we're given 30 miles per hour, and I have two rates that I need to use in order to convert miles to feet and then hours to seconds. So I'm going to use two lines here. I'm going to be multiplying by two rates. Make one red and one pink. So it doesn't matter which rate we start with first. Let's go ahead and convert the miles into feet. So if I have 30 miles in the numerator and I want miles to cancel out, I have to put miles in the denominator. Well, what number's associated with miles? 1. I know that in 1 mile there are 5,280 feet. So that's how I will set up this rate. I want those miles to cancel out. So 1 mile to 5,280 feet will be set up in this fashion. And when we multiply 30 by 5,280, we will get that conversion of how many feet there are in 30 miles. So that was our distance. I'll just label that distance. The other piece we need to convert is our time. So let's go ahead and write that here, time. I have 1 hour in the denominator. So again, I want my hours to cancel out and I want to be left with seconds. So how will hours cancel out? They will cancel out if I put hours in the numerator. So 1 hour in the numerator, and let me use the rest of the rate to 3,600 seconds. Okay. And again, in this fashion, hours cancels out with hours. What units will we be left with? Aha, feet per second. And isn't that what we want? To know how many feet per second we're given? Absolutely. Now, I am multiplying all of these rates. It really doesn't matter which I multiply by first, whether it be the time rate or the distance rate, because of the commutative property. But here I've set it up in this fashion, so we'll just go with it. Now, we multiply fractions like we multiply fractions. 30 times 5,280 times 1 will be in the numerator, and 1 times 1 times 3,600 will be in the denominator, and I'm going to include my units here. We need to go ahead and do this calculation, so here's where you are allowed to use a calculator. You could simplify first, absolutely cross off a 0 to make the math easier if you'd like to. Okay. But using a calculator, we will get 158,400 feet per 3,600 seconds. Now we are almost there. This is equal to 30 miles per hour, but I do want a unit rate. I want to know how fast this bear is going per second. So you may need to make one more adjustment here. To get a unit rate, we will divide 158,400 by 3,600, and you will, voila, get 44. Now, keep the units. 44 feet per second. This happened to work out really nicely, but always read your directions. If you need to round to the nearest tenth or hundredth, please do so if necessary. So we just found out that this grizzly bear, if it's traveling at 30 miles an hour, that's equal to a rate of 44 feet every second. So, could you outrun this bear? You'd have to be very fast. Hopefully the bear will just get distracted and run away in the opposite direction that you're going. So there we go.